Welcome to today's session, students. In the previous class we learned what is the need of a file, what is a file, and how can I access the contents of the file, that is how can I read the file. Today we will learn about the remaining things, that is how can I write the content to the file. To begin with, we have inbuilt C functionalities which will help us to write the content to the file. The first one is printf, that is f printf. Second one is f put s, f put c, and f write is the functions which will help us to write the data to the file. As we have already learnt the function printf, right? We have already learnt the function printf, in which the content was displayed onto the standard input, that is the screen, right? Look here, we have written the name as f printf, that is print something to the file, that is write the data to the file. Similarly, we have learnt put s, which was displaying the content on the standard input, that is the screen. Now I have said it is a f printf, f put s, that is string will be written to the file. Similarly, we had learnt about put c, which will print character by character onto the screen. Now I am writing the data character by character to the file. Similarly, we have one more function called as write, where to write to the file. That's why the function is f write. Look here, to begin with, we'll start with the f printf function. As we all know, whenever we are printing the information onto the screen, what was required is we wanted the format in which the data has to be displayed, right? In that one, we were mentioning, if I am printing the integer data, I used to write %d, that is a format of the data is an integer. Similarly, I used to write %s to print the string. Similarly, to display the float value, I used to write %f, right? Now also, I require the format specification to write the data to the file, but extra argument is file, to which file you want to write the data has to be specified here, right? So what I will do here, initially f print f function will ask to which file you want to write the content, right? Look here, stream is a pointer of the type file here, right? Next is the format information, how the data has to be written to the file. Okay, as I said you, it receives the %sign, it receives the width of the data to be printed, what should be the precision of the data to be printed, what should be the length, right? All the information same as it is in the printf statement, the definition of this goes. We'll learn with one example here. Details.txt is a file to which I want to write the information now. So it has to be opened in a write mode. Okay, as we learnt yesterday, to open a file, I need to pass the path or name of the file, then in which mode it has to be opened. Now I say fp is a pointer to a function, fp is a pointer to a file whose name is details.txt opened in the write mode. When it is opened in the write mode, it allows me to write the data onto it, right? Look here, the same pointer is given here, f printf, where to print to the details.txt file, which is pointed by a pointer fp. What has to be printed into it? I need to print the name and the salary, right? Name and the salary. From where I get the name? I get the name from the variable name. I get the salary from the variable salary here. Look here, I have mentioned the format specifier. Since name is a string, I have used percentage yes here. What should be the width of the name? I tell at the max 10 characters have to be printed, right? I tell, and it has, since the minus sign is used, it should be left justified. Okay, as we all know, salary is of type floating point. That's why I have mentioned percentage F here, right? Salary is of type float. That's why I have mentioned it as percentage F. But within the F, what I have mentioned, 0.2 means after the decimal point, precision should be only 2 digits there. If the salary is 10,000 rupees 50 paisa, I restrict that one to after the decimal point, the precision of the information should be 2. Right? Like this, we can use the function fprintf. Next one is f put s. Right? We are using the function f put s. As we know, the function put s is capable of handling the complete string, a complete line of information, right? So I should mention here what has to be written and in which file it has to be written. It takes 2 arguments, what the data has to be written, next one is in which file it has to be written. Again, I'll take one example. We have to open the file in the write mode. That's why I am opening the comment.txt file in the write mode. Okay, it is opened in the write mode and the pointer to the file comment.txt is fp. Right? I get the feedback from the user. User will enter some feedback. So that will be stored in a variable feedback. Right? Once that feedback is taken from the user, what I need to do, I have to put it into the, I have to dump it into my opened file which is comment.txt. So what has to be put into the file? Feedback. Which file? Which is pointed by fp. Which file is pointed by fp? This is comment.txt is pointed by fp. Next function is put c. Look here, as the character c says, we are writing character by character information to the file here, right? One by one character will be written into the file. So it accepts character by character information and onto which file I need to write the data. Okay, so for that one, whenever I want to write any information to the file has to be opened into the write mode. So I say fopen. Which file is to be opened? This is comment.txt. In which mode it has to be opened? It has to be opened in a write mode. Now fp is pointing to a file whose name is comment.txt, which is opened in the write mode. As usual, user is entering some feedback. It is stored in a variable feedback. Now all the content of the feedback has to be written onto the file comment.txt, but put c will write character by character information. Look here, put s was taking everything together and was just taking the name of the file, but put c is taking character by character information. If the user has entered the feedback as good, if the user has entered the feedback as good, character by character information will be written onto the file. G will be written first, then double O, then D will be put onto the file. That's why what is required for me to trace them character by character? A looping statement is required. From 0th position character till I reach the end of the content, I will go on writing the information to the file. That's why I is starting from 0 till I end with the content of the feedback. What I will write? I will go on writing the content by content, character by character content from the feedback. Into which file? Into the FP. The next one is fwrite function. What this function will do is, it will take the size of object to be written onto the file as one object, right? The size of the object has to be mentioned by the user. Then what I will do, I will take those objects, how many objects I have to put them in the file has to be mentioned. Look here, I'll read the content from a string. I will mention at a time what should be the size of that particular content and how many such blocks I am reading. The last argument is onto which file I am writing the information. Look here, again the file with the name welcome.txt is opened in the right, but it is opened in a binary mode. Okay, I have a string to be placed into the welcome.txt file, which is opened in the right binary mode, whose pointer is FP. Okay, here I will mention I need to write the content from string, right? This content has to be written. What should be the size of the content to be written onto the file? That is the block size, right? I tell size of the string itself is the block size. So how many characters are there? 1, 2, 3, 4, 5. We will be counting the spaces also. Look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41 and 42. 42 is the size of the string, right? So my block size is 42. How many such blocks I want to read? I will be reading one block. The meaning is whole content, which is the whole content of 42 characters, right? This is example for learning fwrite function will be returned to the file pointed by the pointer fp, which is welcome.txt. Next one is, as we know, n number of files are there. With them we are working. So we not be knowing what is the exact size of each and every file with which we are working, right? So whenever I want to read the content, whenever I want to write the information onto the file, or append the any file, what is required is when to end that, right? So when I'll come to the end of the file, that's when we will be learning today, that is detecting the end of the file. Look here, I have a file with the name f1, right? In that one I might have 3 lines and this is the end. I have one more file which may be having around n number of lines and the end is here, right? The end of the file is here, end of this file is here, right? So there is no restriction that all the files are of same size. Okay, that's why somewhere I need to know where should I stop reading the content from the file. I should stop reading the content from the file as soon as I reach the end of the file. That's why it is very much important to detect the end of the file. To detect the end of the file, we have 2 ways. One is we have a standard keyword EOF, that is end of the file. It is a symbolic constant like null, right? End of file is a symbolic constant which will point me to the end of the file whose value is set to -1, right? Look here, I want to read the content of the file whose pointer is fp, right? And I am reading the content character by character because I have used the function get C. Right, till what? I need to go on reading the content till I reach the end of the file. Look here, that's why I mentioned when I go on reading the content from the file pointed by FP, if I encounter a character which is equal to EOF, right, which is equal to a symbolic constant EOF, I should break there. So this is how I can identify the end of the while. Another method is we can use the function called as FEOF, right? I can use the function as either I can go with the symbolic constant EOF, otherwise I can take the help of a function called as FEOF, right? It is also defined in the built-in header file standard input output, that is stdio.h, right? So I say FEOF of file that is pointed by FP. Okay, so what this file will do, if I successfully reach the end of the file, it will return me a true or a integer value 1. If successfully I have read all the content of the file and I have reached to the end of the file, then I will get a signal, that is yes, successfully read the content of the file, I will receive 1. Otherwise, if some error has happened in between, this function will return me 0. This function will return me a 0, saying that there is some error when I was reading this particular file. Look here, you may ask, what are the errors that may occur, right? So when I was explaining you, every time I was using the word upon successful opening, it does some task, on a failure, it does something else, right? Means we'll face some problems when we are working with the files. Let us see what are those errors that may happen when we are working with the files, right? So the thing is, I may be trying to read the content beyond the end of the file. That is, I have reached the end of the file, still I want my file pointer to be moved to the next location, which is not possible because all the content of the file is over, but I am still insisting my file to be read beyond the end of the file. It is one error, right? I may be trying to read that file which doesn't exist only. You might have typed the name of the file wrong, or you might have deleted the file, right? Means you are trying to read that file which doesn't exist. It's an error. Then you may be trying to read that file which is not yet open only. I hope you remember in all the previous examples, the first statement was FP is equal to F open. Means before I start working with the files, I have to open the file. If I asked you to read from the textbook, what you will do? You will open the book first, then start reading. If you will open the book first, then you start writing into it, right? Without taking the book out of your bag, you can't read it, you can't write onto it, right? Similarly, the file also, until it is opened, you cannot access it for either reading or writing. So you may be trying to use a file which is not yet open. Yes, it is an error, okay? And you may be trying to use a file in an appropriate mode. That is, if I have opened a file in a read mode, but you want to write some data onto it. If I am open the file into the read mode, means it is ready for reading purpose, not for writing. That is, you are trying to use a inappropriate mode, okay? And one more reason can be, you may be trying to write the file which is read only file, right? It is write protected. The user has not authorized for you to edit, right? Still you have opened it and want to work with it, okay? So you may be trying to write the information to a write protected file. So these are the possible problems that will happen when you are working with the files. They will be encountered as error. So if you don't handle these errors, your program will abruptly end and you will not be knowing why your program has ended abruptly, right? It is better that we find out the errors and give a meaningful information, and we can control the flow of a program very smoothly. To handle the errors, we have few functions. The first one is f-error function, right? It is a library function. What it does is, it is capable of handling any kind of error that will happen with any file, right? So it is capable of handling all types of error that will occur when you are working with the file, right? So what it does, it checks for the error. It checks for the error. If there is a error, it returns value 0 if there is no error, and it will return a non-zero value if there is an error. If the 0 is received, mean your file is successfully working, and if some problem has arisen in between, then it will give you a non-zero value. Okay, the prototype is, since it is returning either a 0 number or a non-zero number, the return type is int here. Next one is f-error function will ask for which file has to be monitored for error. It asks for a pointer, file pointer, means it will ask us which file do you want me to monitor for the error. Second one is p-error, right? The second function is p-error, which stands for print error, right? Whenever the errors are being handled, sometimes the message that the built-in compiler which will display it may not be understood by the user. That's why I can display the user defined messages with the help of the p-error, right? With the p-error function, what I can do is I can display the meaningful user defined messages depending upon the error number which is returned by my function which is monitoring the error, right? And these error numbers, each and every error that will happen, that is unable to open the file, will have its own number, right? You are trying to write the information to a write protected file, it will have its own number, right? All those error numbers are stored in the built-in header file err_num.h. Depending upon whatever error number you get, you take it as an input and display a meaningful message to the user. Next one is clear error, right? Whenever I am working with the file, somewhere if the error occurs, look here, I have started reading the information from the file. Somewhere when I was at this particular line, an error has occurred, right? Abruptly an error has occurred. Now my f-error function will set a error pointer here. It says beyond this, at this position there is some error, right? What is happen here? Automatically an error point will be set here, a error indicator will be set here, right? Unless this error indicator is cleared, you will not be able to move further with the content of the file, right? So when I know there is a problem in my file at this location, so and remaining all the content of the file are fine, what is required? I need a way wherein I will skip this content and let me move to this location so that I can smoothly handle at least the remaining content. For that one, I take the help of a function clear error. What it does is, it clears the error indicators that are set onto the file. Okay, so it will clear the error flags which are set onto your file. The next part is how I can append the file. Okay, write the file means what? I will be writing the content to the file. Read means whatever the content is stored in the file, I am reading. Appending means I have a file and around 3 lines are already there. I want to put the new data at the end position of my file, right? Means I have already 1, 2 records are there. If I say append from the 4th location, I will write the new information. Okay, for that one, what the thing is required now? Again, the file has to be opened, but this time the file has to be opened in the append mode, which is indicated by the character A. Open the file in the append mode. Okay, when it is opened, the last one is whenever we open the file in the append mode, what I will be doing, I will write something onto the file with the help of either fputs function, fprintf, fwrite, or whatever the functions are told me in the previous slides. They can be used to write the information to the file. Then I need to close the file which was opened in the append mode. Okay. So let us take one example. Let us assume we have opened the file in which I have stored the student information. Okay, student.txt is a file in which I am storing the information about the students. What all information of the students are present there? I am storing the information about their roll number. Then I am storing their name and what are the marks scored by them. Right? Yesterday I have already entered first 3 students information. Today I have got a time and I want to again edit my file with the new students information.